Greetings to you all. My name is Ronald Lukanga from netLabs University. I hold a bachelor's degree in telecommunications engineering with a strong background in networking technologies, mobile cellular and wireless communications. I'm here to present to you a research paper titled Leveraging TV White Spaces for Rural Broadband Connectivity. And to give you a short background, netLabs UG, a research center of excellence in telecommunications and networking technologies, who had its origins in the Community Wireless Research Center, CWRC, located at the Department of Electrical and Computer Engineering, at Makerere University, is piloting a scalable model that is titled Rural Broadband Connectivity Network, RCBN, for rural and the underserved areas in Uganda using TV white spaces. This is a case for Apache district in northern Uganda, and it is in support of the knowledge-based economy with a focus on agriculture, education, entrepreneurship, and health. The primary beneficiaries of this network therefore will be farmers groups, education and health facilities, and other selected community sectors. This network will help the local government and civil society groups to improve on service delivery. The network will also serve as a platform for rural innovations for socio-economic development through hosting of ICT applications selected and tested to assist in delivery and monitoring of government services, education, and enhancement of farmer productivity and market access. In addition, the project will set up and pilot a district information knowledge portal, the DKIP, where all information and communications regarding the district will be posted by the different stakeholders. This is in support of the demand side for the rural connectivity model, and since the DKIP will be hosted locally, information will be freely available to all the users in the community. Over the time, various technological advancements have emphasized the need for research and innovation in new trends to cope up with the ever-increasing requirements in wireless communication. The capacity of existing cellular networks has been saturated due to high increase of services, thereby posing the need for a viable broadband solution. While most of the urban areas are already covered by a mobile network, many rural areas are still without any broadband connection. In low development countries such as Uganda, 17% of the rural areas do not have any mobile coverage, and 19% of this is only covered by a 2G network. And looking at a global scale, 72% of the homes in urban areas had connectivity before 2019, almost twice as much as the rural areas. In Africa, only 28% of the homes in urban areas have access to internet, and this is still just 4.5 times higher than the rural areas. So in this research, we explore the use of TV white spaces as a sustainable and low-cost connectivity model for rural broadband in rural areas. The main objective of this research, therefore, is to present to you a detailed discussion of TV white space technology and the opportunities for rural deployment in development countries, the regulatory policies, and the challenges that must be overcome in the use of TV white space. The specific objectives of this research, therefore, are exploring the different opportunities for rural deployment around the world. We investigated the challenges facing deployment of TV white spaces in all the communities. We also presented policy challenges that must be addressed for the successful exploitation of TV white spaces in these communities. Looking at the overview of the TV white space architecture, this topology includes a point-to-multipoint with a base station equipped with directional antennas and a consumer premise equipment, that is CPEs. The TV white space master, therefore, queries the spectrum regulatory body to acquire a list of official database operators. This means operators that have gone through a qualification process whereby the spectrum regulatory body tests them to gain assurance that their databases meet the specified terms and conditions before approval is issued. The master TV white space device therefore queries the certified operators for available TV white space bands, and the TV white space database performs calculations for the given parameters corresponding to the TV white space device, after which it informs it of the available bands and the transmission power that should be used in any transmission. In our methodology, an analysis of various channels, articles, and textbooks relevant to TV white space technology was done. Information regarding the TV white space deployment in rural communities in development countries was obtained from articles, project websites, and online journals. Policy handbooks were used to obtain information regarding the policies facing the implementation of TV white space in different countries. To obtain information on the challenges surrounding the deployment of TV white space in various countries, scientific websites and interviews with various industry players were also reviewed. Looking at the deployment scenarios of TV white space, we noted that there are several scenarios appropriate for the deployment of TV white space, as illustrated in the example below. This can be employed in systems for providing rural broadband connectivity. It can be used as backhauls for communication links, deployments in critical environmental situations such as after natural disasters, geolocation services, and distribution of local information. Opportunities for deployment of TV white space in rural environment, therefore, arise. TV white space can be used in disaster response. This technology finds use in various applications such as restoring connectivity to areas faced with natural disasters such as earthquakes and landslides. In healthcare care, TV white space technology is being used to remotely connect patients in rural areas with specialists to avoid traveling long distances for consultations. In education, numerous pilots have been deployed to provide connectivity to students and teachers in various schools in order to promote equitable learning, research, and innovation. South Africa carried out one of the first large-scale TV white space trials in the world, which targeted the improvement of the education sector in rural areas and communities. Tyberg was selected as the center hospital for this TV white space network because of the availability of support from Tyberg to host the base stations, availability of good backbone internet connection, and ability to connect a number of schools from this central location. Lastly, in agriculture, TV white space is being used in this sector to increase farmers' awareness of their farms, leading to increased productivity and lower costs. For example, FarmBits is an IoT platform that is being used to enable precision agriculture applications on farms in Washington and in New York. In our research, we were able to identify the different challenges facing the adoption of TV white space. Although there is lack of awareness of opportunities arising from the use of TV white space, the major constraint is the lack of conducive regulatory environments in most of the countries. Onerous requirements and license fees have been placed on small companies that would like to set up trials and deployments of the TV white space technologies. In addition, access to masts has been made highly expensive due to lack of infrastructure sharing, resulting in poor service provision. The notable lack of expertise in this field in very many countries has also posed a threat to the filtration of the TV white space technology. For TV white space use in mobile networks, access to the radio spectrum bands has also been restricted since the GSM band is only allocated to existing operators and the frequency reuse is prohibited even in areas that are not occupied by licensed operators. Similarly, the LTE bands are only available at very high costs. The stringent terms set on the location of the TV white space database makes its deployment very difficult since it cannot be located across the borders. Finally, the geolocation database approach, which is considered as an alternative technique to sensing, is not suitable in Africa and other development world due to low internet penetration index. In conclusion, TV white space technology provides a quick and cheap pathway towards enhancing rural broadband connectivity, especially in the rural and unserved areas. In this paper, we highlighted the use cases of TV white space technology in such settings and described the challenges that face its wide adoption towards shrinking the widening digital divide. Developing nations have realized that provision of ICT services and information access in rural areas is a great growth booster to the economies of such areas. TV white space technology is a great option towards accelerating provision of such services. With its long range and wide length bandwidth, TV white space can facilitate innovation and the use cases in important sectors such as agriculture, healthcare, entrepreneurship, and education. However, governments have to deliberate in promoting this technology by putting in place the right policy framework for its adoption. There is also need to leverage relationships of various organizations that promote welfare of people in rural communities, such as the UN, with the national policymakers and the regulators to sensitize them on the potential for community networks and the need for regulatory fees. Below are some of the references that were used in this presentation, but the paper contains quite more than this. Thank you for your time and your interest in watching and listening to my presentation.